Good morning, all of you. Last class we have seen the refraction through glass slab. In the glass slab, there are two refractions. One is from rarer to denser, where the light ray bends toward the normal, and second one from denser to rarer medium, it's where the light ray goes away from the normal. The emergent ray is parallel to the direction of incident ray. I think all of you can recollect the diagram, ray diagram, refraction through glass slab. Emergent ray is parallel to the direction of incident ray. Therefore, angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence. That is, angle of incidence is 45 degree, angle of emergence is also equal to 45 degree. Emergent ray is parallel to the incident ray direction. And there is no deviation in this. Deviation is equal to 0. Because emergent ray is parallel to the direction of incident ray. But emergent ray is laterally displaced, and we can see that lateral displacement. So there is a lateral displacement in the case of refraction through glass slab. So last class there was a question, that is the last point, when light travels from rarer to denser medium. For example, air to water or air to glass, the velocity of light decreases. So does the reduction in velocity or speed of light imply a reduction in the energy carried by the light wave? This is a very important point. So when light travels from rarer to denser medium, example from air to water or air to glass, velocity decreases. We can calculate this by using the equation n equal to c by v. We have already calculated. So what you can say about the energy carried by this light wave? Light is an electromagnetic wave. Energy is given by E is equal to h nu. Energy of light wave depends only on frequency. Okay, it is independent of velocity of light in a medium. It depends only on frequency. But during refraction, frequency remains constant. Frequency remains constant. Therefore, there will be no change in the energy of light wave. What is the energy in air medium? That will be the energy in water or in glass. There will be no change in the energy. Of course, there is a change in velocity. So, energy carried by light wave, okay, depends only on frequency. According to the equation E equal to h nu, I think all of you can recollect this equation was already given to you. E equal to h nu. Energy depends only on energy of light wave. It's electromagnetic wave. Depends only on frequency. E equal to h nu. Frequency remains constant during refraction of light. Therefore, there will be no change in the energy. Okay, so this is very important point. Why frequency remains constant? This is because of resonance oscillations. In higher classes, you will learn about this point. And I think all of you can recollect laws of refraction. Incident ray, normal, refracted ray all lie in the same plane. Snell's law of refraction, refractive index is related to sine of angle of incidence and angle of refraction by the equation n21 equal to sine I divided by sine r. Refractive index is related to the velocity n21 equal to v1 by v2. If the first medium is air or vacuum, then we call this refractive index is called it as absolute refractive index. Today I am going to give some important examples. Okay, some important points are here. Just like we'll see, you might have observed that the bottom of tank or a pond containing water appears to be raised. That means if you place a coin in a glass of water, then the coin appears to be raised. Why? the water tank appears shallower. So, best example is a coin placed in a glass of water appears to be raised. That means the image position will be above the actual position. Why? This is because of refraction of light. Refraction will be from water to air interface. I am going to draw this diagram. Another case. The last class we have seen glass slab. So when you place a glass slab, okay, over a letter, printed matter, you can see that it appears to be raised. So why this? Again, this is because of refraction from glass to air interface. So these two diagrams I'm going to explain here. And another important point that is already given in your NCRT. For example, suppose you are placing, have you seen a pencil which is partially immersed in water in a glass tumbler? It appears to be, that means bend. The displays, that means there will be a bend at the interface. When you place a pencil in a glass of water, at the interface you can see a bend there. What is the reason for this? This is again because of refraction of light. So I am going to explain these three cases. This is all because of refraction. Okay, a coin placed in a glass of water appears to be raised, or a glass slab, if it is placed over a printed matter, it appears to be raised. If you insert a pencil in a glass of water, you can see a bend at the interface. These are all because of refraction of light. So we are going to see the diagram for that. Okay. So first diagram is, suppose an object is placed in water, in a glass of water. Because of refraction, it appears to be, the position appears to be raised. So we'll see the diagram for that. This is because of refraction. Some examples of refraction. Example number one. Example number one is, okay. So this is a glass of water. So we are placing an object, this interface, this is air, or this is water. So an object is placed. For example, a coin, etc., is placed in water. It's water here, and we are placing a coin here. So an object is here. This is the coin. Any object is here. A coin is placed here. We call it as an object. And we'll see the refraction. What happens here? First ray of light goes from water to air directly along normal incidence to the point. This is the point here A. OA is along the normal, so goes without any bending. There will be no change in the path. It goes straight. Okay, it goes straight. It's called normal incidence. There will be no refraction in this case. There will be no change in the path. So it goes straight. For a normal incident ray, it goes straight. Another ray of light from the object, say coin, etc., that is reaching the interface. Second ray, I am marking here. And this is the point here, normal. And you know, it is water is a denser medium and air is a rarer medium. So therefore, the ray bends away from the normal. Bends away from the normal. This is angle of incidence, angle of refraction. So you have two rays after refraction. The first ray is here is going like this, second ray is here. If you are observing from here, you can see that this you are standing here, observer is here. Observer eye is here. Rays 1 and 2, they are not going to meet anywhere here. They are not going to meet anywhere here, but appears to come from. So if I am extending this ray backward, this ray is extending backward. So for an observer, if you are standing here, these two rays appear to come from a point here. So where you get the virtual image of the object. That means the position of the coin will be here. This is the position of the coin. So this is the reason for this position of the coin. So usually we say that a coin placed in a glass of water appears to be raised. Why? This is because of refraction. Refraction is taking place from where? Refraction is taking place from water to air interface, denser to rare medium. Okay, so I explain this again. So usually we say that bottom of a tank or a pond containing water appears to be raised. That is the sentence for the statement. Or water tank appears shallower. The meaning of this statement is that if you place an object in water, then the position of the object will be above that because of refraction. So how will you explain this? See, this line stands for the interface between air and water. O is an object, example, a coin in water placed. First ray going along the normal. This normal incidence goes straight without any change in its path. Goes straight. It's a normal incidence. And second ray is reaching here obliquely, going from denser to rarer, bends away from the normal. If you are standing from here, okay, somebody is standing here on right side. So these two rays are not at all meeting anywhere here. But you can see that they appear to come from a point I, where you will get the virtual image of the coin O. So you can see that. So it is appears to be raised. The position of the object appears to be raised. So image is coming to this point. So this explanation for this. So same case can be explained. So you can see that suppose you are using a glass slab. Last class we are seeing the glass slab. So when a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? What is the reason for this? It is again because of refraction. So same diagram can be used. So instead of water, we can use this word. Just complete the diagram. This is a glass slab. Also, I am keeping the glass slab here. Same. There is no change absolutely. Instead of water, we can take it as a glass medium. This is the same diagram. So this is an object just placed here at below. So this is a printed, any printed letter or any other things, you can see that it appears to be raised by because of the same reason. So explain this with the help of diagram. So why a coin placed at the bottom of water appears to be raised, or any printed matter when observed through a glass slab appears to be raised. This is because of refraction. Okay, this is example 1 and 2 we have seen. Next one. One is for coin placed in water appears to be raised, and printed matter when viewed through a glass slab appears to be raised. So two diagrams are similar. There is no change. One more example is given this. In NCERT, have you seen a pencil which is partially immersed in water in a glass tumbler? Okay, we have seen that. It appears to be displaced at the interface of air and water. What is the meaning of that? That means there will feel a bend. Okay, we will feel a bend at the interface. So how will you explain this? We are going to explain that. Next diagram for that. Example number 3. So we are taking a pencil which is partially immersed. Some part of the pencil is inside the water, and we see what happens here. So you can take a container. We take a container. We can take water inside. So this diagram is an important point. Explain with the help of a red diagram why a pencil partially immersed in water appears to be bent at the water surface. Okay. Yeah, this is a water surface, and we are going to keep a pencil, etc. here. So this is your you can keep a pencil here. Okay, this a pencil is here. Yes. So some of the portion is inside. This a pencil is kept here. Okay, a pencil. It's partially immersed. A O is your pencil. O I am marking is here, and from here this much portion B. BO portion is inside water. AB portion is outside. Okay, pencil is immersed, partially immersed in water. Then we see the ray diagram for this. So from the tip of the pencil, that is from O, I'm going to make some rays. One ray of light coming from here reaches the interface. This is the interface. This is the water interface. This is air. This is water. So this is the ray. One ray from the tip of the pencil reaches at this point. So we can make a normal at this point. We make a normal. Normal is made. Then bends away from the normal. Bends away from the normal. One more ray, we can take another ray of light from the pencil, tip of the pencil reaches this point. And here also we are making a normal at this point. I make a normal at this point, normal is made. Bends away from the normal. Again bends away from the normal, so it is going in this way. You can see these two rays after refraction, ray number 1 and ray number 2. They are not coming closer, they are going in diverging and going. Okay, this ray is going in this way, this ray is going. So if we are observing from here, somebody is standing from here to see these two rays appears to come from a point somewhere here, extending them back. Extending the back. So they appears to come from this point here. So when they are appear to come from the point here, we'll see the pencil, the appearance of the pencil will be in this format. So the tip of the pencil will be here. Yes. The tip of the pencil will be here. So therefore you can see a bend at this point. Instead of seeing here, there will be a bend. At the point you can see that there is a bend. So this is the diagram for this. Why a pencil partially immersed in water appears to be bent at the water surface. I explained with the diagram. So this is your pencil kept here, or is the tip of the pencil. One ray is coming here, going away from the normal after refraction. Another ray also is coming here, bend away from. These two rays are not meeting anywhere. So for you, if you are standing here in air medium, so these two rays appears to come from a point O. So the pencil position will be, it will be like this, appears to bend. So you can see that a bend here at the interface. Okay, this is the reason. So three important points are there. All three are important. One, so a coin placed at the bottom of a water tank or in a glass of water appears to be raised. Explained with the diagram because of refraction from denser to rarer, that is from water to air. Okay. Another thing, a glass, any printed matter, when observed through a glass slab, when it is placed over it, appears to be raised. Again, same reason, refraction is from dense to rarer, that is from glass to air. So why a pencil partially immersed in water appears to be bent at the water surface? Again, because of refraction from water to air, that is denser to rarer. Three examples and with diagram you can see here. So they are very important point. Okay. Next, we are going to see next important point. So when light ray travels from rarer to denser, bends toward the normal. You remember the point. So I'm giving some other points here. So angle of refraction is less than angle of incidence in this case, and the speed of or velocity of light decreases. So all of you please recollect this point. Frequency remains constant. Then when light goes from denser to rarer, bends away from the normal, velocity of light increases, angle of refraction is greater than angle of incidence. Again, frequency remains constant in this case. Okay, frequency remains constant in this case. So these are the important points in this case. Next is we have different types of transparent media. So first one we have seen glass slab. Next one we will see Lens. So next topic will be lens. What is the what is the lens? How can you form a lens, etc. So that is also very important point. Second, and image formation through lenses. So how can you explain a lens? So refraction through glass slab we have seen. So glass slab faces are actually parallel. We know the shape of the glass slab. Now here we see lenses. So next we'll see refraction by spherical lenses. Refraction by spherical lenses. Refraction by spherical lenses. Okay. So how will you explain a lens? It's a transparent medium material bound by two surfaces, of which one or both surfaces are spherical. Okay. Both surfaces can be spherical, or at least one side can be spherical in shape and other can be a plane surface. So lens here we mean it's a transparent material bound by two surfaces. There are two surfaces here, of which one or both surfaces are spherical, forms a lens. This means that a lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. So this is the way how we cut this transparent medium. Okay, you have a transparent medium of glass. So we can cut in different ways to form two surfaces. So this is the way. So how will you define lens mean? It is a transparent material bound by two surfaces. Of course, two surfaces should be there, of which one or both surfaces are spherical, forms a lens. So this is the definition of lens. So what is the meaning is that this means that a lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. So if you take a lens, so a lens may have two spherical surfaces, okay, or one spherical surface or other one plane. So two surfaces are there. So important point is two surfaces. We can see two surfaces there. And these two surfaces can be spherical. So both surfaces can be spherical, or it can be one spherical surface. One spherical surface, and second one can be one plane surface. In all this, so we call it as a lens. So transparent material bound by two surfaces. Lens ka definition is this. So transparent material bound by two surfaces, of which one or both surfaces are spherical, forms a lens. So two surfaces can be spherical, or one surface can be spherical and other can be plane. So different formations. So there are two types of lenses. So there are two types of lenses. Types. First one we call it as a convex lens, and second one we call it as concave lens. First one is convex lens, second one is concave lens. What is speciality of convex lens? Convex lens, you can see that there are two spherical surfaces. They are bulging outwards in one way. So two spherical surfaces, both are spherical, bulging outward, or one spherical surface and other can be plane surface. This is the way you can cut it. Concave lens mean there are two spherical surfaces, but it is in this form. They are not bulging outward, they are bulging inwards. Okay, so we can see in this case, two spherical surfaces, they are curved inwards. Concave lens means that there are two spherical surfaces, they are curved inwards, or at least one surface is curved inward, other can be plane surfaces. Okay, we have seen glass slab. Glass slab is like this. So these two refracting surfaces are plane. exactly plane, parallel. A lens means bound by two surfaces, and both surfaces can be spherical, or one can be spherical, other can be plane. So two different types of lenses, convex lens and concave lens. In convex lens, first option, there are two spherical surfaces. These two spherical surfaces are bulging outwards, or one surface is bulging outwards and other can be plane. In concave lenses, first option, two surfaces are there. They are spherical, they are curved inwards, or one spherical surface which is curved inward, other can be plane. So define a lens and what are the different types of lenses. So two types of lenses, convex lens and concave lens. So in the first one, here we see that both surfaces are sphere, and this we call it as double convex lens. This we call it as double convex lens. And here one side is bulging outward, other is plane. So this we call it as plano-convex lens. Okay, plano-convex lens. Here in the case of concave lens, there are two surfaces, concave surfaces, bulging, that means curved inwards. They are called double concave lens. And one side is plane, so we call it as a plano-concave lens. So I am drawing a little more bigger diagram for this. So convex lens, concave lens. Two spherical surfaces curved outward, this we call it as double convex lens. Double convex lens. Or one surface is curved, other surface is a plane. So this is called plano. One side is plane, plano convex lens. Next one is concave. Two surfaces are spherical, they are curved inwards. This we call it as double concave lens, or simply concave lens we call it as. Or next one surface is curved, other is a plane surface. And this is called plano concave lens. Plano concave lens. So two lenses. First one is both sides are curved outwards, and double convex lens. Usually we say simply convex lens. And one side is plane, it is plano convex lens. And here it is, both surfaces are concave, curved inwards, double concave lens, or simply we call it as concave lens. And one side is a plane. So that is to be especially mentioned, plano concave lens. So lens mean it is a transparent medium. It's a transparent medium. Okay, it's made of glass. It's made of glass. It's made of glass, transparent medium, bound by two surfaces, 1, 2, 1, 2, 1, 2, and 1, 2, of which one or both are spherical, forms a lens. I think it is clear now. So what are the speciality of convex lens? You can see that the surfaces are bulging outwards. Okay, spherical surfaces are bulging outward. So in such cases, you see convex lens middle thickness is greater and than at the edges. End thickness is less, and here the thickness is more. This is the way how we can recognize. So convex lens is thicker at the middle as compared to the edges. So this is the way how will you check it. So if you feel that it is thicker at the middle than at the edges, then it's a convex lens. And what about concave lens? You can see the measurement thickness. Here you measure the thickness, and here you measure the thickness, edges thickness. You can see that. It is thin in the middle region. At the middle, it is very thin. And thickness is more at the ends, at the edges. So this is the way how you recognize the concave lens. Concave lens is thicker at the edges than at the middle. 2 points you have to remember. Suppose you are given two lenses, if they are thin, you have to recognize. Simply by observing by your eye, we may not able to recognize. So you can touch and feel that. So if you move your finger over that, over the lens, and if you feel that it is thicker at the middle, then it is a convex lens. If it is thin at the middle, it is a concave lens. This is the way we can recognize. You can experience this in the lab. So convex lens thicker at the middle and concave lens it is thin at the middle. You can see that in comparison with the edges. Convex lens also known as converging lens. So why it is on the we will explain. Converging lens and concave lens we call it as diverging lens. Why it is we'll see on the way. Convex lens is known as converging lens and concave lens is known as diverging lens. Now some of the important points, just like in the case of mirror, we are seeing what is the pole of the mirror, what is the center of curvature of a mirror, what is radius of curvature, what is the focal length. Similarly, we have some points here also. So that I am going to mark here. So diagram is already here. We'll see in the case of convex lens, we have two surfaces. Mainly we discuss with word double convex lens. So if a convex lens is given, that is a double convex lens. Okay. So in the case of convex lens, concave lens also, two surfaces are curved. This is a curved surface, this is also curved surface. This is also curved, this is. So we can see that it's a part of a sphere. The first surface, you can see it is a curved portion. The center of this surface will be lying on right side. That is C1, we mark it as C1. It is the center of curvature of the first curved surface. Okay, this is the curved surface. So it's a part of sphere. If you see like this, a part of sphere, its center will be lying on right side. It's a point you have to take, important point. Similarly, the second surface is here. Second surface, if you extend, it will be like this. So it's a part of sphere. Its center will be lying on left side. So this is second surface. So we call it as C2. So if I draw this one, you can see that first surface is extended like this. You can see that. Yeah. So first surface center will be here, and the second surface is curved like this. So its center will be on left side. C1 and C2. So C1 is on right side and C2 is on left side. Similarly, we mark. So next point will. So two centers we are seeing. If you draw a line passing through the two centers of curvature, and that we call it as principal axis. Okay, it's a straight line we are drawing. A straight line passing through the centers of curvature of these two. And this we call it as principal axis of the lens. Principal axis of the lens. Okay, other points will continue in the next class about the lenses. Thank you.